Hello, everybody. We're going to go ahead and get started on today's Enhance Your IQ session. My name is Heath Houghton, and I am the product manager of our fluid flow simulation products at Autodesk. In particular, Autodesk CFD. As you might have seen or heard, we just released a point release update, 2018.1 for Autodesk CFD. And I guess the major theme around this update is enhanced cloud solving. One thing to keep note is that in the past, when we had a point update, 2018.1, for instance, in this case, but 2017.1, 2017.2, they were typically just bug fixes. But as we move forward with our continuous improvement, continuous development cycles, you should see more often that these point releases actually have extended functionality within them. And that's what you're going to see in this case of 2018.1. There are obviously bug fixes and continuous improvement for existing features, but we'll be offering new features as well in many of these point releases. So today the session is going to be around what is in 2018.1, and then also I expect to have a lot of Q&A at the end because we do have a brand new set of functionality that there will probably be a lot of questions around. So what is actually in 2018.1? Obviously, there are some bug fixes, some localization issues. For instance, like Korean language had some issues with localization as we went to release. So we fixed those, right? Some of the geometry handling's been updated. So we also had some Creo geometry handling updates. And then other things, just major points are a lot more than this. These are some major bullet points for people that might have experienced some performance degradation resolved. Remote solving was resolved for 2018.1. And the major one is that somehow Windows or our cloud service provider changed the way that we could detect the number of cores on our instance machines as we moved into our 2018, what we call channel. And we were for a while there only actually utilizing 4 cores for the solve. So you might have seen a slowdown in 2018 as opposed to the 2017 release when it came to cloud solving. Once we were notified, it did take a client update, so we had to wait until we could do a client update, and which means a point release. And we're back up to 8 cores, so anybody who's been waiting and thought they saw some slowdowns on the cloud, you're right, and we fixed it. So back up to, we had to change some code in order to be able to detect the right amount of cores and utilize everything that we're actually paying for on the back end. So everybody's back up to 8 cores, which is phenomenal. The other thing is we've been unofficially supporting Windows 10. Personally, all of our AEs, our application engineers, our tech support, myself included, we all have Windows 10. Anybody with a newer laptop computer has Windows 10. And we didn't officially support it at release. It's officially supported. That means if something comes in as a bug that's Windows 10 related and it's only Windows 10, we can officially support it, which means we can fix it in a timely manner. Whereas before it released, we weren't sure. We knew it would install, but we needed to make sure all of our development resources were geared up for officially supporting Windows 10. It's just a minor thing, but it's officially supported. So if you have a company that says we can't get software unless it's officially supported, you're good to go there. So it's kind of a big deal from that standpoint. But from a day-to-day use, we just double-checked everything, and it just goes into our continuous release process. So the big ticket item, when I said new functionality, so that's all back-end stuff, right? That's all what we should be doing, fixing things, making things run better, all that kind of stuff. But Cloud Premium, it's a new service. It's finally here. I've talked about it, I've alluded to it in the past. We were going to do some distributed memory solving on the cloud. And this has been a huge multi-year effort. And I don't mean like 1 or 2 years. I mean multi-year, working on the architecture for a long time. And it's HPC on the cloud. And this is big because this is our first foray into high-performance cluster computing on the cloud. we've done high performance computing on the cloud already with our current cloud solution. It does, I think, really well on the cloud, integrated solution, no effort other than just hitting solve and get your answer seamlessly up and down from the cloud. Now we have the ability to seamlessly do the same type of event, except we're clustering multiple worker machines together on the cloud dynamically as you hit solve. And that's for a bunch of games. I'll go into the details here and I'll actually show it in action. But basically, it's a subscription customer access. So if you're a subscription customer, with 2018.1, you'll see Cloud Premium as one of the solving options. And again, this is a brand new service. We expect it to evolve, and I'll go into the details of what it does currently, what we expect it to do in the future, and how we expect it to actually help you get bigger problems solved faster. So it's a completely different solver, Cloud Premium. I don't want you to think that it's, you know, the same thing we've been doing with cloud entirely. The workflow is the same, and we want it to look seamless. If you were to pick Cloud Premium versus cloud, or Cloud Premium versus local solve, we want it to look identical as far as the overall workflow and the way you determine the solution finish, all of that stuff. You know, all your results viewing, all that's the same. But it's a completely different solver. So what I mean by that is it was rewritten from the ground up for distributed memory solving. What that means is computers that are just connected by a network, they're not on the same, you know, motherboard, whatever. So when you're on the cloud, all these different computers that are just communicating to each other. It's written from the ground up for that type of a solution. And like I said, there's patents and all that kind of stuff applied for regarding the way we do it. But basically, the way it works today is there are multiple Amazon EC2 instances working on the same problem, whereas cloud standard is a single instance. The benefits that we, you know, should be getting from this are performance gains. And that's flat out what it's for. And performance gains are, one, you have a distributed memory footprint, which means you're distributing, since you're distributing the problem across multiple workers, that means that each one of those workers is only taking a chunk of the problem. It doesn't have to take on the full load of a very large mesh. It just means that you can solve larger problems because you don't have to keep increasing the size of the machine in order to solve the same problem or to solve the larger problems. But what also is happening, because you're distributing that compute, you're breaking the problem down into smaller chunks, is that you should be getting iteration speedups. So overall, it means you're efficiently using the hardware where you can solve bigger problems and you can solve them faster. So there are current limitations to it. Luckily, with these limitations, they're just really certain physics are excluded and certain material models. So just certain aspects. You can't solve everything in Cloud Premium that you can solve in cloud, but you could solve most problems in Cloud Premium that you could solve in cloud. But the major bullet points on what you can't solve in Cloud Premium are, you know, motion and rotating regions, and then certain material models and derived results are excluded from being able to be solved. So as we released, you know, this last week, compact thermal models and thermal comfort aren't included. Now, the thing is, you don't have to memorize these things as a customer, as a user of the software. Well, all you have to do is, if you pick something that Cloud Premium cannot solve, the interface will tell you. So it's not like you go to solve and it comes back with bogus answers. It'll just tell you, hey, by the way, that's not currently supported. And then the next time we support it, you know, we'll update the interface and we're going to be adding to Cloud Premium's capabilities as we move forward. So what does it do? It does a lot of things, and we'll talk about the performance. So the major thing is that the way I want to talk about performance is, you know, there's a bunch of ways to benchmark a solver and all that type of stuff. What I'm doing is trying to do it as easily as possible without confusing things for people, is talk about performance compared to what they currently know. And so what you currently know in the cloud with Autodesk is our cloud solution. So Cloud Premium, the comparative benefits are really just that with distributed computing, the speed and problem size benefits that you get. Really, as mesh count increases, you'll start seeing more performance out of cloud premium in comparison to cloud. What that means is for smaller problems, you're probably not going to see much of a gain, if any at all. So like a 1 million element, maybe even 2, 3 million element models. The current cloud solution is so finely tuned, and we've had it for so long. We've tuned that thing just to the nth degree that you're probably not going to see much gain on those smaller problems. So it may not be something you could test it out, but you may not see much. You may not want to use it for that. But as the mesh count increases, the expectations are that cloud premium outperforms, and it starts getting to where the more and more mesh count you get, so the larger problems you get, starts to significantly outgain just the regular cloud solution. That's because that's the power of what distributed computing gets you. So what does that mean? It just means we're going to be producing some benchmark results. We're going to have knowledge articles coming out, blog articles on our Sim Hub, all of that with different specific benchmarks. And that's all that come out here soon. But I can use some general guidelines. I have a graph here which shows which physics kind of work best. But basically, certain physics currently scale better than others. Steady state flow analysis by far have the best performance gains. Thermal, if you add thermal to that, so conjugate heat transfer analysis, that's steady state, that'll slightly reduce the performance gain for the thermal portion only. So it's a little bit of a bottleneck on the way we do solving with distributed computing. And then if you add buoyancy effects, that'll kind of reduce it a little more. So you kind of start scaling back the benefits, right? Transient problems, we allow you to solve transient problems on Cloud Premium. Right now, the benefits are minimal. So it's really, to me, it's only really if you want to solve a transient problem and it's just maybe too big for the cloud solution, then you might try the Cloud Premium. But for performance, not the greatest. Awesome. So I was getting some notifications from the webinar that they wanted to change my hardware. Not going to happen. Okay, the other thing is the reason for the varied levels in performance is really network latency. So it all has to do with the hardware and tuning the hardware in the background. The nice thing about this technology, and the reason we released it as is today, is because we expect there are a lot of customers that could really see some great benefit. And this technology is going to grow. What I mean is the code is already in place to poise, and it's poised to capitalize on further hardware gains as we reduce the network latency on these distributed clusters. We'll capitalize immediately on the different physics to be able to gain the same kind of performance gains we might get on, what is the highest performance gainer right now, which is steady state flow analysis. So by stating that, what I mean is Cloud Premium is just going to continue to be tuned for performance. And a lot of times that tuning will not require a client update. So we don't have to put out a 2018.2 or a 2018.3 in order for people to start seeing performance benefits. So, it could happen on a weekly or monthly basis where certain things just start working faster. Sometimes it might require a client change, which means a point release. But the point of it, my topic there is that we're going to keep continuing to tune for performance. But I want to emphasize that doesn't mean that the answer is changing. Like a converged solution is a converged solution with the solver. We're not changing that, right? That you're going to continue to see the same good results. It's just you might get it a little faster as the weeks and months go by. So this is an initial offering, and we've done tons of testing, a lot. That's why it's taken so long to get out. But my experience as a product manager is you can go through every known scenario and all the models that you can come up with to test out a fluid flow solution. But there will be customer models that may challenge it and that we can learn from and make things better. So If you end up using the service, thank you. If you end up using the service and you get good results, we'd like to hear about it. If you get poor results, let us know, because we can take that model, run it, tune the solver, much like we've done in the past with our cloud, our regular cloud solution. That's been, you know, that solver has been tuned over the last 15, 20 years, not 20, but 15 years or so. And we can do similar things, but on a much faster rate with Cloud Premium. And so your continued feedback is very important to us. Okay, enough about that. And I'm about to get out of slideshow mode and actually show what it looks like in the software, so you can get an idea of what it means to run a Cloud Premium job and what the effort level is, because it's very minimal effort. I just want to show what it looks like so you know what to expect. But the expected performance is really exactly like I said. If you're going to compare the two, let's go to what you already know, and that's cloud. And then we have the Cloud Premium service. So your speed up on your X or Y graph, your element count, typically in the millions. We're not talking, you know, small changes in element count. We're large changing in element counts here. Lower element counts, like I stated, pretty much going to get similar performance. The speed up is going to be right around, the speed is going to be right around the same speed as regular cloud. As the element count increases, what we are expecting to see in the current offering as it exists today is turbulent flow will just continue to get faster and faster in comparison to the regular cloud solution. And like I said, there's a little bit of a drop off in performance when you add the forced convection, but it should also outperform cloud as the element count goes up. You add natural convection and transient, the effects start to go down a bit. As the solution progresses, or as the offering matures even further, we expect that to all of these other physics types to start to catch up to the turbulent flow type of speed up gains. That's the general mode. So if it were me as a user, I would definitely, if I had a turbulent flow model, valve, whatever, external flow, doesn't matter, I would probably, and it had a pretty large element count, I would test it out and see what I got, right, as a tester. And by the way, the answers, because it is a completely different solver, are never going to be identical, but they should be very similar. All the testing shows just a few, like maybe a couple percentage points off for exact meshes, difference in the solution. So yeah, you don't have to worry about that. You know, the different answer to the different solver, you get a very, very similar answer. But we expect, I would run turbulent flow, forced convection, like you know, conjugate heat transfer, steady state with constant fluid properties. That I would probably run. The natural convection, the transient, I might run one as a test case just to see, but I wouldn't count on those to have great performance gains right off the bat. But again, the solution has great promise for those problems as well, and it's going to progress. And as we see huge gains, we'll continually update you guys. That's enough talk about, you know, what it is and what it does. I want to show what it is in the software. So we're going to go ahead and switch over to Autodesk CFD 2018.1. What I have is this valve model, and it has the exact same setup for both models. And I set this up with a small mesh just so we could, you know, get it running on the cloud pretty quickly. And the basics are nothing changes for the user except this. Like if I go to the solver manager, you can see I might choose cloud for one, and then the other solution, I can just choose Cloud Premium. So the one thing you're going to notice is there is a difference in cost. We are incurring a huge cost in the background increase because of the increased amount that we're going to throw at the problem as far as hardware. So there is an up cost to utilize it, but like right now, for instance, we're using way more than 4 times the resource at the problem. So we're really offering a substantial discount in order to really just help grow the capabilities ourselves. We want people to utilize it, we want people to gain benefit from it. So we're going to use it as I guess what you would call cost leader, or I don't know if you were going to call it that, but yeah. So you're getting a great amount of added resource for really less than what it really costs by far. Anyway, the deal is here, you don't have to do anything except hit solve, just like you would normally. And you can do that from the solver manager or from just the solve dialog. It's the same process. One thing to note, once it starts running, we'll see here in a second, it's going to go ahead and upload the model to the servers, and you'll start seeing some messaging. And the only difference in the starting of the solution is that, first of all, it has to upload the solution to the cloud, just like everything else. You'll start seeing some messaging around setting up the cluster, and it'll tell you, hey, it's setting up the cluster. And to make sure you know that we're not getting any, so you can see I have a solution running in the cloud right now, and these two are solving. What you'll get is some messaging inside the software of preparing the cluster. And it takes around 5 minutes to set up that cluster because we're setting them up dynamically. So we're going to message you in the output bar and in the bottom left-hand side of your screen, letting you know that that's the operation that's happening. So if you don't see results instantly, there's a little bit of overhead to set up those clusters. So you see it'll say that, hey, we're waiting until those cluster instances are ready. That'll take 5 to 10 minutes. My experience, it's more like 4 to 6. But we want to be conservative on the number that we estimate for you guys, so we said 5 to 10. And every minute it'll give you an update that, hey, it's still working, don't worry, this is not a frozen screen. And then at the end you'll start seeing the results just like you normally do on regular cloud. So that's the way it works. I think while this is going, because it's like it's a 4 to 6, we don't want to sit here and watch paint dry. Let's go ahead and open up for questions. Whoa. Okay. All right, I'll kick off with a couple of my own questions. So I've had questions about, does the solution, look much different? What's the compatibility with the current solvers? And so I'll start answering some of those questions, and maybe it'll spark some more questions from the attendees. But this is about 2018.1, so I'll recap. Windows 10 support. The regular cloud is utilizing all 8 cores again. We've done some bug fixes, which we don't usually get into those in depth. Just realized we concentrated a lot on geometry, the localization, and we actually have a larger point release regarding performance and stability coming out pretty soon. We'll have another webinar around that. But the differences on the solver are that when you solve Cloud Premium, the way it works currently is if you want to continue a solution with Cloud Premium, you can only utilize Cloud Premium to go to continue forward because it is a different solver. They're not cross-compatible. You get very similar answers with Cloud, Local, or Cloud Premium, but Cloud Premium solves if you want to continue that solution. Like let's say you solve for 100 iterations and want to go again and continue from 100, you have to utilize Cloud Premium again. That's one of the nuances of the solver. But, I mean, it's just the way it is when you have different solvers. They can't read each other's data typically. And then the other question about the solution answers, what I've seen in the solution answer is the velocity profiles, the temperature profiles will all look very similar. The main difference that you will see is in the number of iterations it takes to get to the final fully converged solution. What we call solution control in the background, which is controlling how fast to move forward and still keep a solution stable, and how many iterations it takes. That is a completely different scheme for this new solver. And so we've tried to get it to be very comparable. So if you're used to running something for 250 iterations to get a well-converged solution or a fully converged solution, we've tried to make the numbering of the iterations that you see on the client, what you're actually seeing as your inputs, to be very similar. Having said that, still could be off by, let's say if it took 300, it still could take 400 to solve to full convergence with Cloud Premium. The reality is we're actually solving a little bit tighter convergence with Cloud Premium by default, and just the way this stuff happens in the background, no two answers are alike for any problem. So it may solve a little bit faster in number of iterations, it may solve a little bit more iterations. It's just going to be very similar. Is all we can really promise there. So what I've been doing is solving everything to convergence, and like in this model, I stayed 1,000 iterations. I know it'll be done by 1,000 iterations. It'll be somewhere probably between 200 and 500 iterations typically, and that's what I've seen for these models. So I just specify 1,000 and run it, and then I get more and more experience. I might lower the iteration count, but I don't do an exorbitant amount of iteration requests. I don't say 10,000, and I don't say just 100. I just state something that I'm pretty sure it'll be converged by. That's my rule of thumb. That's the way I roll them. Yeah. Okay, so we are starting to see some questions. So do we need to worry about large element counts, and is there a restriction of RAM? The reality is we already have a really high amount of RAM for the workers on the cloud, and I haven't seen a lot of restrictions on element count, but there eventually would be, right? You're going to run to a 100 million element model. It may or may not run on the cloud, depending on the mesh and the solve. You could hit a limit there. The cool thing about Cloud Premium and being distributed is that same 100 million element model would be distributed across multiple machines. So each machine is only seeing the memory requirement for a small portion, and the large element count restriction just immediately just goes away, even if there ever was one. So the answer is a little bit more complex. We don't really have our RAM limitation is pretty minimal on cloud. We have a very high RAM count on each machine, but on super large models, you just won't run into it at all with Cloud Premium. So you can see here on the messaging while we wait for any more questions, it says waiting for 1 minute, 2 minutes, 3. Like I said, typically it's like 4 to 6 is what I've seen. So after 6 minutes, it's saying the cluster is ready. It's going to do some quick checking just to make sure all the communications are in order. And then the solution will start. So it'll start meshing and do everything else that you normally see on the cloud. And so the messaging will start to be very consistent after that, what you're used to seeing when you run cloud problems or cloud simulations. So you start seeing it loading the mesh sizes and all of that. So by the way, this is the way we initially roll it out for simplification. Like, hey, we're going to set up the cloud. It's going to mesh. It's going to do these things. One thing you might notice is that it'll talk about a meshing override. So being a totally different solver, the wall layers are now going to be always a tetrahedral element. What does that mean for you as a user? As a user of our software, you don't have to change anything. It automatically does this. It's just the way the solver was written, is that it uses all tetrahedral elements. The wall layers will still be the same thickness. They'll still have the same distribution of nodes, and we actually always solve the nodes anyway. It's just the way the mesh is. So you'll see that little messaging override or meshing override message. It's just letting you know that that's a change that's happened automatically in the background. And then it will go to mesh and run. But like I said, we don't necessarily need to watch the solution. I wanted to watch how it kicks off. And then from here on, it's the same regardless. Now, if you're in your if you ever utilize the Simulation Job Manager, you would start to see the same thing. So, you know, running solution, how far along in has it gone, all that kind of stuff happens. So here you can see the cloud job on the smaller job actually has a head start because it didn't have to set up a cluster, and so it had that 6-minute head start. It's already, you know, churning the answer. So that's why I say on a lot of these smaller problems, you know, cloud is oftentimes it could actually outperform cloud premium, even though there's more hardware being thrown in the cloud premium because there's some overhead on the setup. So yeah, that's the way it works, and you start seeing this roll out just like it does on normal cloud problems. It's just utilizing more hardware, and you'll see a message about how much hardware here in a second, how many worker machines it's throwing at it. Yeah, so you see CFD2. We call it CFD2 internally. It's just a way to shorten Cloud Premium or whatever the service is. That's the solver, we call it. And it's using 16 machines. So it's using 16 machines as opposed to 1 on the same problem. Yeah, so yes, it looks normal just like everything else. You start seeing the solution progress. Still do the same actions that you normally would do, you know, post-processing and all of that. I like to use certain things in software. So I'll just show the mesh so you guys can see that other thing that I was talking about. So the distribution is still going to be the similar. I threw a coarse mesh on here just so it would get through that meshing process quickly, and so we could just really quickly see. So the mesh looks different as far as now they're tetrahedral, so instead of being prisms, you see, you know, triangles in here in this cross section. But the distribution is going to be identical. If I were to show you that on the other problem, the node placement, you wouldn't be able to tell the difference except for the fact that there's tetrahedrons in here instead of prisms. So everything else, your mesh controls, everything's the same. Your nodal distribution, very, very similar. You might only see a difference of a couple of nodes count difference overall between a cloud premium solution and a regular cloud solution with the same mesh settings. Okay, let's see if there's any more questions. Oh, okay, I see. So cloud premium versus normal cloud. The way we're going to go to market, or the way that we've gone to market with it right now is we're going to always tell you in any cloud job or cloud premium what the cost is ahead of time so that you can utilize or make the decision before you're obligated to the charge what it is. So when you hit solve or when you hit the solver manager and you select cloud versus cloud premium, it'll tell you what the charge is. And right now it's a simple multiplier. We still have the same simple, moderate, and complex pricing structure when we're looking at, you know, how complex of a problem are you trying to solve, basically how big and complex physics is it. But when you hit the cloud premium, it's just going to, because we're throwing so much more resource at it, we're just going to do a 4x multiplier. And as you saw in the message window, we're throwing 16 times the resources at it, or actually a little bit more than that, but the 16 worker machines are being thrown at it. So we're really not trying to just add the cost to the user. We're trying to make it to where this is a benefit, but we can still make it to where it doesn't drive us out of business. That's the pricing scheme right now. Again, these things are all subject to change eventually in the future. Price, you know, it's harder to go up than it is to go down. So the price may even go down as we more effectively utilize resources. But that's the way it works today. And if there's a pricing update, obviously we'll let you know. And the software will always let you know what the price is ahead of time. So is there a roadmap for additional features to the scalable solver? So the CFD2 scalable solver, you might hear that same nomenclature throughout. Yes, there's a roadmap for additional features. Right now, we are in the final stages, even as we push this out, to push out yet another update. We expect within the next month sometime in November, we expect another update to come out, and that will have obviously some performance and enhancement upgrades to the interface itself and different things we have within, CAD updates, whatever, within the software. But what we also expect is that there are any additional items that we've been working on as we continually work on this scalable solver will roll out with the update. So right now, what we have slated are electronic specifics material models, compact thermal models, and thermoelectric devices, things of that nature. Those are things that we are actively working on in the near term. And then as we move forward, some of the things that I expect to come out after those are sort of completed are the AEC related derived quantities. So I think actually Cloud Premium really suits itself well towards architectural engineering construction type problems. What I mean by that is those models are typically very large because they're external aerodynamic. A lot of times, it's wind wake studies of cityscapes. It's a building with a bunch of terrain around it. There's a lot of detail. Even the interior details on a lot of the architectural models, if it's an interior model, have a lot of mesh count. And so what we expect to see are those models benefit greatly from Cloud Premium. So those are on the pecking order as well, on the priority list, is the derived quantities for thermal comfort and stuff like that. Right now, you can solve pretty much any radiation's already included. All of the physics are there. It's just getting the derived quantity to show up in the user interface, being able to communicate those effectively as thermal comfort, persons dissatisfied, all of that stuff. Those will be on the list to come out shortly. There are questions about the highest element count the dev team has tested on. And the reality is we've tested on hundreds of millions of elements. Really, the solver can solve like today for Cloud Premium, the actual solver itself, it's like 300 and something million elements. And that has nothing to do with the core technology. It's just like when you start storing things, is it an integer? Is it, what level of an integer is it in the background code? So how much, all that kind of stuff just has to get changed over time to store larger and larger numerics. And 310, I think, has been the largest model that we've solved on it currently. But our goal in the long term is 1 billion elements. And when I say that, I say it kind of with a slight laughter because that just seems imperceivable when you think about it. You go back 5 years, 10 years. I've been doing simulation for a long time, and used to be 1 million elements was a lot. Now we're talking about maybe 1 billion. The solver is one thing. You have to make sure the mesher can do the same number of mesh count, and then most importantly, can you even display it? Can you get that into the onto your computer and display it? So I think when we start hitting these larger counts, and this is all futures talking, I think that hardware limitations will start to become more of an issue than the actual software itself. And so the larger and larger models, I foresee that it'll be a cloud workflow just based off of what your infrastructure can handle. And a cloud infrastructure can be more controlled, and we can still beam the results, but in a way that a regular computer or a handheld device could actually see large mesh count models and be able to utilize it. There's not all the data is sitting there on that machine. So I think that's where we'll go. But right now it's in the 300 million element range. That can be kind of hard on a lot of hardware for visualization. So I wouldn't say go out and try to put a 300 million element model on it. Just saying that's what the actual physical limitation is right now in the software. So the question came about core counts. The reality is, what I was talking about earlier is we have 16 machine workers. The type of worker is actually even bigger than the worker that we solve with cloud. And I have to go with a little bit of a description of why we choose, which workers we choose for the, or have chosen historically for the cloud, and what we've chosen for cloud premium is the current solver that we have that solves your local solution in cloud is a shared memory solver. And what that means is that all the cores really have to sit on the same hardware. You can't connect different hardware together and it's solving the same problem. When you have that type of an infrastructure, there will be a limitation on how many cores you can effectively solve. What we have seen is the benefits past 8 cores for our current solver. It really solves well. It's so finely tuned for up to 8 cores. Anything past that, there's just hardware limitations that you're not really milking anything extra out of it. And so that's why we've chosen an 8-core machine, physical core machine, as the solver or as the worker machines for cloud. Now, for cloud premium, all those limitations start to go away for a majority of the solution. There's still latency issues which slow down certain physics, and we're going to work through those and get around them as hardware gets better for latency, network latency, and as we figure out more novel solutions for that little portion of the solve. We may change the hardware to get faster benefits. We're never going to change to get slower. We're just going to always try to get faster. But right now, what we're using are actually 16-core machines. We're still experimenting off of production, so away from what the customers see on is 16.8, is there a real benefit with the other latency things that are going on, really making sure that we finally tune it to get as fast as we can. And as we change the fine-tuning of how it controls those resources, we may change what the resource gets thrown at it over time. But the promise I can guarantee is we're always striving towards faster, and that's the whole goal. And we'll always tell you what the core count is, or the machine count is, what we're throwing at it. If there's a question about that, we can always tell you, but it always tells you in the software right now anyway. But that's what it is. It's actually 256 cores today. That's what we're seeing solve right now. Which is crazy, right? I don't think any customer really has access to that. I mean, some people might on their internal networks, but do it without any configuration and without any hassle of setup and resource monitoring and all that kind of stuff that goes along with certain high-end architecture. Is none of that has to be done by the user, so it's pretty cool. I think I had a question also about new physics, multi-phase, phase change, boiling, condensing, free surface without having to run transient and stuff like that. So we continually look at physics. I think what happens is I don't have anything where I can say we're coming out with a new physics in the immediate future. We actually are looking at new solving technology all the time. And it just, new solving technology, for anybody listening on the webinar, is it's usually a long lead item. You can't say, well, we're going to go tackle this physics, and then it just happens the next release. It usually takes a couple of release cycles at least to get anything new out that's a new technology that's novel, that hadn't already been done by somebody else, or that, you know, gets a lot of benefit. And so we're actually looking at, in the background, another type of solver as well, which, get back to the original question, lends itself better to a lot of these multi-physics type of problems. And I can't make any promises about it. It's all an experimental. But when we start to see something readying for commercial release or getting ready for that, we'll likely, with that one, start to expose it to users in a beta program or whatnot. But we're not there yet. Yeah, the question is, are we experimenting with new physics? Yes. Do we have anything ready for release? No. So I think Oh, so this model right now is not very large. It's like just over 1 million elements. And like I was saying, the smaller mesh count, because you're having to distribute that problem and then bring it back, smaller mesh counts don't see a ton of gain. So this one solves at about the same rate you would expect the regular cloud solve to run. And that's the reason I chose it, because I don't want to give false expectations that smaller jobs will suddenly run instantly because you're throwing all the hardware at it. Really, there's like a sweet spot for number of million of elements per core when you do distributed computing, and this is well below that sweet spot. So really, distributed computing, what it allows is larger models to be more successfully solved in a time frame that's acceptable. If you try to solve a 45 million element model right now with cloud, depending on the physics, it might take anywhere between a day to 3 days, right? The expectation is that we could solve that a little bit faster, potentially a lot faster with distributed computing. But a 1 million element model solves in an hour. It might solve in an hour with cloud premium. It might solve in 30 minutes. It just depends on the physics and specifics of that problem and the way we control the way the solution control is happening in the background. Yeah, so that's kind of the way it works. So I didn't want to put the wet blanket on how fast it solves, because this problem is not going to solve super fast in cloud premium. I wanted to show the workflow, but if this were a 30 million element model, I would expect it to solve faster than a regular cloud solution. And that's expectations. If you start running problems or simulations where you're like, well, I really didn't get much performance gain out of that, we want to hear about it, because all that really is the technology exists in the background. It's, are we utilizing the resource effectively for that problem? You know, do we need to tune our what we call solution control, and how fast and how little we relax the solution to make sure it's stable? We might need to fine tune things a little bit here and there, and that's what happens with experience. And that's what we've done over the years with our current cloud and local solver, as we've tuned that over several years and just experience. There's no you can do any amount of testing that we can do, as many permutations, different types of models as we want. There's always going to be a customer model that may be a little bit different, that may challenge the solver a little bit, that we can learn from and just have algorithms in the background to figure out that challenge and work faster. So that's things that we count on from our customers. To, if you see something that if you test it and you see that you don't like something that's happening, let us know about it. If you like something that's happening, let us know about it. It helps us make sure we're just gives the developers, in my perspective, a little reassurance that people are seeing benefit from this, and we're happy to see that. I think those are all the questions that I've seen. I think that might be it. I haven't seen another question come by in about 5 minutes, so I just want to reiterate, and I'm going to go back to my presentation. What is 2018.1? First of all, expected performance, and that's on the cloud in general, right? Because we solved an issue that we had for cloud that basically doubled the performance back to what it should have been, along with other benefits that we did to the solver in general, but the cloud solution in particular. We got it back to running on 8 cores, so there's performance there. But for larger models specifically, we should start seeing added benefit with Cloud Premium, which is a subscription entitlement. And if I can go back up to the beginning, there were other benefits in 2018.1. There were some, obviously we have a ton of bug fixes, and remote solving being one. If you did a remote solving, if you don't know what that is, that means we have what we call local solve in the software, but you can also solve on another machine that's on your local network. It's technically a remote solve because you're initiating the solve from a different machine to another, but it's locally solving on another machine on your network. There were some communication issues there, so we resolved those issues, and then some geometry handling with Creo and updates for other CAD have happened in between. But the bigger one, also Windows 10 has been officially supported. just want to recap on what's there. It looks like we have no more questions, so I think we can go ahead and end the webinar.